dear students, we are on the CC Gurukul lecture and we are in the series of electronic circuit, and we discuss the many components which are used in construction of the electronic gadget. In the today's topic, we are discussing the digital circuits. In the digital circuit, how we prepare the digital circuit? Digital electronic circuits can be prepared by using the gates. So, in this lecture we are discussing the what are the gates and extended gate, the types of the gate we will discuss. Previously we have discussed the three gates. One is the AND, OR and NOT gate, which are the basic logic gates. In this lecture we classified the gates into the further categories, like the logic gates can be classified into the major types. Number one is the basic logic gate, that are the AND, or NOT gate. Other type of the logic gates are the universal logic gates. These are the digital electronics components, and two logic gates are considered as the universal logic gate. One is the NOR gate and another is the AND gate. So, we will discuss these two further. Apart from this, we are having the derived logical gates and other gates also, which are the XOR gate or XNOR gate. We will discuss further in this lecture. So, previously we have discussed the AND gate, where we discussed that we are having the two input and having the one output, which is the product of the two input. And next we discuss the OR gate, where we take the two inputs and addition of that will be the output. So, A plus B will be the output of the OR gate. After that we discuss the NOT gate, which will the which is the inverse of the input, where that's why we define it as input, as if input is 0 then output will be 1, if input is 1 then output will be 0. And we discuss the various symbols as well as we discuss the various tables regarding that. Now, next is the NOR gate. What is the NOR gate? As the name suggests, NOR, NOT plus OR. So, NOR gate is a type of universal logic gate that can take two or more inputs but one output. Similarly, we can take one and more input in as like in other gates. So, this NOR gate is also have the two or more inputs and have the one output, and it is basically a combination of the two basic logic gates as is defined as OR and NOT. So, OR and NOT, when we put it together, when we combine these two gates together, then we get the NOR gate, and the output is basically depend upon the what input we are giving. So, in other words, NOR gate is an OR gate followed by a NOT gate. That is why it is a NOR gate. There are the basic properties of the NOR gate, but we discuss the two important properties. NOR gate can have two or more inputs and gives an output. Another is the NOR gate gives a high logic 1 output only when its all inputs are low or logic 0. It means we can get the one output when all the inputs are low or all the inputs having the 0 value, then only we can get the on output. So, similarly to the basic logic gates, we can describe the operation of the NOR gate using the mathematical equation that is called the Boolean expression. Whenever we define the gate equation, then it is known as a Boolean expression of the NOR gate. Now, you see that it is C is equal to A plus B bar. NOR, it is means inverted OR. So, C which is the output is equal to A plus B. We are having the two input, the addition of that and then inverse we will take. The so Boolean expression of the two input NOR gate is given below. Now, we can extend this expression to the number of the input variable. It means we can put the number of variables in input variables like A, B, C, D. Similarly, we can add these inputs to get the output, and we take the inverse of that. Now, in the above Boolean expression, variable A and B are called the inputs and the variable C is called the output. So, we have this type of Boolean expression. Now, if we talk about the truth table, now you see here, you see only we are having the output 1 when both the input are 0. So, A is 0, B is 0, then A nor B will be 1, otherwise other outputs will be 0. So, this is the truth table for the 2 input for the NOR gate, and the relationship between the input and output is as 0 0, then the output will be 1. If 0 1, output will be 0. If it is 1 0, output will be 0. If 1 1, then again it is 0. And you can compare it with the an OR gate where we have the inverse of that. Right. Now next is you see the symbol of that. You see that this is the similar to the OR gate, but a dot in front of the output is here. This is the comparison of the OR gate and NOR gate. We put this dot represent the negative or the inverse of the OR gate. So this is the NOR gate. Now next type is the NAND gate. What is the NAND gate? Means inverse of the AND. So in digital electronics, the NAND gate is another type of the universal logic gate and used to perform the logical operation. Like NAND gate performs the inverted operation of the AND gate. So similar to NOR gate, AND gate can also have the 2 or more input and having the 1 output. AND gate is represented by the combination of the 2 basic logic gates, AND and NOT gate. So AND gate is equal to AND gate plus NOT gate, and it is having the property like the NAND gate can take 2 or more inputs at a time and produce the 1 output based on the combination of the input we are applying there. Next is the next property, that is we can easily understand that NAND gate produce a low or the logic output only when its all input are high. Means when 1 1, then output will be the 0. So when we are having a high inputs, the output will be low. When we are having the input 1, then the output will be 0. So if we can describe the expression of the NAND gate through a mathematical equation, it is called the Boolean expression, then it is written as C is equal to A dot B inverse. So now in the expression, A and B are the input variable and C is the output variable, and we can extend this relation to the number of the input variable, that we can take 3, 4 and 5 and more. So now you see this is the symbol. You see that the symbol is same as a NAND gate, and but the dot is here, that dot represent the inverted of the AND gate. So the logic symbol of the NAND gate is represented as the NAND gate, and is bubble, you can say bubble or dot on it output is depicted in the following figure, and it is a symbol of the 2 input NAND gate. We can take the again we can take the 2 or 3 or more input in case of the AND gate. Next is the XOR gate. In case of the digital electronics, there is a specially designed logic gate named the XOR. That is another type of gate where we define the XOR. XOR means XOR, which is used to digital circuit to perform the modulo sum. It is also referred to as the exclusive OR gate, or that is, or we can write it as EXOR gate. So XOR gate is the exclusive OR gate. So XOR gate can take the only the 2 inputs at a time and give an output. The output of the XOR gate is high or the logically 1 only when the 2 inputs are dissimilar, means either 0 or either 1 input with the another input, then can only give the output high, otherwise it will be the 0. So it is very easy to understand, remind it that we can remember it as like that, if we are having a the 2 inputs are dissimilar, then we can get the high output. So what are the properties of this? It can accept only the 2 input at a time, and there is nothing like 3 or more input in case of the XOR gate. Means we are having only the 2 input in this case and 1 output in XOR gate. So the output of the XOR gate is logic 1 or the high. When its input are dissimilar. So, the operation of the XOR gate can be described through a mathematical equation in the Boolean expression like that. You see, there is a plus and the round is in, plus is in the circle. So, this is the expression for the XOR gate. Z is equal to A plus with in the round B. There is Z is the output variable and A and B are the two input variable. This expression can also be written as the A is equal, Z is equal to A B bar plus A bar B, means one is inverted, another is simple, another is inverted and another is simple. So, Z is equal to A bar B plus A B bar. So, this is the truth table of the XOR gate. Now, you see 0 0 0. Now, you see we are having the two high output here. When we are having the two output high here, when their input are mismatch, like when it is 0 1, then the output is 1, when it is 1 0, the output is 1. So, we are having the two dissimilar input, then the output will be the 1, otherwise it will be the 0. Now, this is the symbol of the XOR gate. You see that there is a curve in the input side. So, this is basically this is the symbol of the logic gate XOR, and here we are having the two input and one output, and one curve is there, extra curve is there in the A or B. So, next is the XNOR gate. XNOR gate means when we invert the XOR gate. You see that on the last line you are having the representation that the XNOR gate is equal to XNOR gate is equal to XOR gate plus NOT gate. So, XNOR gate is another type of the special purpose of the logic gate used for implement exclusive operation. These basically are exclusive, have giving the exclusive expression, and in digital circuit it is implemented the exclusive NOR operation in the digital circuit, and it is also called the XNOR or the exclusive NOR gate. So, exclusive NOR gate, and it is combination of the two logic gates XOR and the NOT. So, output of XNOR gate is high when both the inputs are similar. It is just opposite to the previous one, XOR gate. So, here the XNOR gate is used as a similar detector circuit. So, what are the properties of this? XNOR gate takes only the two input and produces a one output, and the output of the XNOR gate is high or the logically one only when it's similar input. It means we are having you can see in the truth table that how we can take it. The operation of the XNOR gate can be described through the mathematical equation which is called the Boolean expression, which is XNOR, and it is expressed as y is equal to A B plus A B bar. So, we can represent it as a dot and in the circle. So, A and B are the input and Y is the output. Now, you see the truth table A and B. You see that when the inputs are similar, the output is high. It means with 0 0 and 1 1, then we are having a high output 1 1. Otherwise, it will be the 0 0 means low output. Next, this is the symbol. Now, you see XOR gate is here, and there is a bullet in the output. So, it is a XOR gate, is XNOR gate with the XOR with the negate output. So, the logic symbol of XNOR gate is shown in figure as we are having here. The A and B are inputs and Y is the output. What are the basic applications of the logic gate? Logic gates are a fundamental building block of all the digital circuits and the devices and the computers. We can use it here. Here are the some key digital devices in which the logic gates are utilized to design their circuits, like computer, microprocessor, microcontroller, digital and smartwatches, smartphone, etc. Now, what is the essential way to learn logic gates? How we can easily learn the which logic gate we can use, which input and output we can get. So, there are some functions we have to learn, instant function that easily we can define, that this AND gate give this output, this OR gate give this output. So, AND gate, if both the inputs are high, then output is also high, as we seen in the truth table. So there is some functions, there are some fundamental points which can easily demonstrate the gates. Like AND gate, if both the inputs are high, then the output will be high. OR gate, when minimum of one input is high, then output will be high. In other words, we have the XOR gate. If minimum one input is high, then only the output is high. If minimum one input is high, then the output is high. In the NAND gate, if minimum one input is low, output is high. We are talking about the high output. When we are get the high output, when in the AND gate, when both the inputs are high, output will be high. In the OR gate, when minimum one input is high, output is high. When XOR gate, minimum one input is high, output is high. In the NAND gate, if minimum one input is low, then the output is high. If it in the case of the NOR gate, if both the inputs are low, then the output is high. So these are the some points by keeping in mind, we can easily get the high output of the any gate. Easily we can, these are the some functions. Now next is the De Morgan principle, De Morgan theorem, how it is used. The first theorem of the De Morgan start that the logic gate like NAND is equal to the OR gate with a bubble. Like we can see that output of these and NAND gate is equal to the OR gate with a bubble. Like the logic function of the NAND gate is defined as A dash B is equal to A dash plus B dash. Second is the second theorem of the De Morgan state define that the NOR logic gate is equal to the AND gate with a bubble. Like NOR gate with the AND gate with the bubble is the NOR gate. In this case, OR gate with the bubble is the NAND gate. OR gate with the bubble is the NAND gate. If we are having a AND gate with the bubble, then it is a NOR gate, just opposite of that. The logic function of the NOR is similarly here, A plus B dash is equal to A dash dot B dash. This is a Boolean expression. Now you see how we convert the NAND gate. This is a conversion of the NAND gate. The NAND gate can be formed using the AND gate and the NOT gate. Then it is a NAND gate. The Boolean expression of the truth table is shown below. We can see here. This is the NAND gate. Here we are having a inverted NOT with the NAND gate. So this is basically a symbol. We can write it as also AND gate with the NOT gate, forwarded with the NOT gate, or we can put a bubble in front of that. And the truth table we can have y is equal to A dot B dash. So here we see that all the inputs high, if all the inputs are high here, when it is the case when we are having the now you see here output y a b, when then we can take the inverted of that, that will be the y, that is the invert of the AND gate. So invert of the AND gate means we are having the, if we are getting a high output, in which case when the both the input are high, but in this NAND gate the output is low when both the input is high, just inverted of the NAND gate. Now see, next is the NOR gate conversion. NOR gate conversion we can do through the OR gate plus NOT gate, forwarded with the NOT gate. You see you can put a bubble here. So this is the NAND gate. This is the truth table. You can see y dash a plus b is defined as the OR gate. After that, when we take the invert of that, we can get the NAND gate. This is basically a NOR gate. NOR gate, which is basically a OR plus NOT here defined. Now you see 0 0 1 0 1 1 0, and here 1 0 0 1 and 1 1 1. Then output will be the 0. If 1 is 1, then the output is 1, but in this case inverted, it will be the 0. So you can easily match that, a plus b 0 1 1 1, but here y, which is an OR gate, it will be the 1 0 0 0. XOR gate you can see. Now this is the basic conversion. You see, first we take the inverted, after that the one input will go inverted in the one of the gate, AND gate. So XOR gate can be formed using NOT and OR gate. XOR gate we can prepare by using the NOT gate, AND gate and OR gate. The Boolean expression of the truth table we have given, again we will show that it is A plus B round B. So this logic gate can be defined as a gate that gives the high output once any input of this is high. If one input is high, the output will be high. If both the inputs of the gate are high, then the output will be the low. So this is the symbol. We are having the two inputs. First we use the two NOT. One inverted input will go in the AND gate. So first you see that A inverted go into the, and B positive will go to the AND gate. One negate input will go in the AND gate. After that the output will go pass through the OR gate, then we can get the output. So this is the symbol. First two NOT gate, after that two AND gate, then one OR gate we will use, and this is the physical symbol. Now easily we can see on the screen that this is the our gate, like you see here, A inverted will go into the first AND gate, and the positive B go into the AND gate. Then output will be the Y is equal to A bar plus B, and this output will go into the OR gate as the input. Now you take the another AND gate input. You see here A positive will go directly, but here the B is negate, or B inverted will go into the second this AND gate, and after that we can get the Y dash, which is equal to A plus B bar. And now this A bar plus B and A plus B bar go into the OR gate, and this will be multiplied, then we can get the output. So that's why total Y is equal to A bar plus B into A plus B bar, and this is basically a symbol. Now this is the truth table of the A plus B. You see here A bar B plus A B bar. So you are having the output here. If you give 1, 2, then you can send the output. If you put the 0, if we put the A, then we put A is equal to 0, B is equal to 0, then Y is the 0, A is 0 and B is 1, 1, 1, 0 is 1 and 1, 1 is 0. It means an inverted will give the, if the two are dissimilar, will give the output high. Thank you very much.